Hello, Algebra 2 students. This is Mr. Bear, and I am here to talk about Skill 2, which is transformation of functions. For this activity, I did this with Desmos last year, and it really worked out well. So what I'm going to do is I'm going to navigate between the notes here and Desmos. And what we're going to do is we're going to generalize some transformations to those parent functions you learned in the last lesson. A couple things to note: when you're using Desmos, when you're trying to do absolute value of x, you have to type ABS parentheses x. And when you're trying to type square root of x, you have to type in SQRT and that'll allow you to get the square root function. Okay? So what I'm going to do is I'm going to type these equations into Desmos, but first I'm going to identify the parent function. So the parent function for y equals x squared plus 2 is y equals x squared. And in black, I'm going to actually graph what that looks like. Okay, so y equals x squared looked like, oh, that's terrible. Here, I'll graph that a little bit better. So y equals x squared looked a little more like this, okay? So what I'm going to do is I'm going to use a red color here, and I'm going to take y equals x squared plus 2 and put that in Desmos. So when I'm in Desmos, I can just go to the graphing calculator, and I can type in y equals x squared. So I have to use this little keypad function to get my squared, and then plus 2. And you'll notice it looks just like y equals x squared, but now we have the vertex point at the point 0, 2. So I'm going to go back to my notes here. Like I said, I'll use red to do this. I'm going to plot that point here and draw what I saw in Desmos. Okay? For the next one, again, I'll switch to black. The parent function here was y equals absolute value of x. So that looked like a graph like this, and it kind of looked like a V. So now we're going to see what happens when we have absolute value of x minus 3. So I'm going to clear this function out, and I'm going to type in y equals ABS x, and then I'm going to do minus 3. I'll move this out of the way, and if we look here, we can see that what was the origin as our vertex now becomes the point 0, negative 3. So I'm going to plot that. I'm going to use red to show my transformation. And when I do that, I'm just going to plot my negative 3, and the graph just looks like this. Okay? For the rest of these, I'm just going to go off of memory because you should have learned your parent functions. Square root of x is the parent function here. That graph kind of did something like this. Now, if you look at the first two functions, you probably notice that the number at the end told us where to go up or down from our starting point. So you can kind of generalize here. If I have a plus 4 here, you may be thinking, oh, well, that's going to start up here. And then the rest of the graph is going to look just like the parent, but it's just going to be moved up or down. Y equals 2 to the x minus 2. The parent function for 2 to the x, you may remember this is the one that has a y-intercept of 1. It kind of did this. Well, let's talk about what happens if we put that minus 2 at the end. That just means that we're going to take this point here, shift it down 2. This is the one you have to be careful about because when you have y equals 2 to the x, that actually had a y-intercept of 0, 1. So y equals 2 to the x minus 2. You're shifting down 2 units from that y-intercept. So this y-intercept is 0, comma, -1, because to go from 1 to -1, you go down 2. But the rest of the graph just kind of follows that same pattern. So if I generalize and talk about this plus k as just being the number at the end, we're going to say that the k value tells us how much to shift up or down. So k shifts graph, shifts up or down on the y-axis. Now, a lot of our functions have a vertex at the origin, so a lot of times that number will just simply tell you where the graph is going to have a y-intercept. But just note that these graphs here, this exponential graph here, is the one oddball. Okay? So just be careful about that. All right, let's look at what happens when the plus k is inside the function itself. So we have a function of x plus k. All right, so again, I'm going to draw my parent functions first. So the parent function for this first one is y equals, so notice we have something squared. So again, we're talking about the parent function y equals x squared. This one, the parent function is y equals absolute value of x. So remember that has a point at the origin and looks like this. This one is y equals square root of x. So that's the graph. The parent looks, whoops, that's a little bit high for the parent function. Kind of goes a little more like this. And y equals 2 to the x plus 3. Remember, 2 to the x has the intercept at 1. And it goes up like that. So now these parent functions, I'm going to go to Desmos and see what happens when I have a -3 in parentheses here. Okay, so now I'm going to type in y equals x minus 3 squared. And notice that this graph ends up shifting to the right 3 units. So I'm going to go to my graph. I'm going to graph this in a different color. Let's use orange, I guess. So we went right, and then everything else about the graph looked the same as the parent. Let's see what happens to the absolute value when I have plus 4 here inside the absolute value. So I type y equals abs x plus 4, I think. Yeah. And notice that the graph shifted over to -4. Okay, so when I had the plus 4, it shifted over to here. And the graph looked like that. When I do square root of x minus 2, so you may be noticing here, you might be thinking, okay, this said -3, but I went to the right 3. And this one said x plus 4, but I went left 4. So this one, if this is x minus 2, what do you predict will happen? If you said it'll go right 2, you'd have been correct. And then this one, if this says plus 3, I bet you're thinking, oh, we must have went to the left 3. So the graph would look kind of like this. All right, and you could explore Desmos if you wanted to look more into that, but just notice that when you have the k, in this case, so when you have f of x plus k, the graph shifts, so it shifts left or right, and I want you to I call this the weird one, so it does the opposite of the number. So left is going to happen when you have a positive value, and right is going to happen when you have a negative value. Okay, and you'll get used to this as we practice more. All right, let's look now at what happens when there's a negative in front of it. So if I put a negative in front of my function, so x cubed, we haven't looked at this one yet, at least not in this example, but you saw this in the parent functions. X cubed is the one that kind of looks like a tall snake, sort of does this. Negative, okay, so that's the parent function. I should be writing that. This parent function, y equals absolute value of x, we know what that'll look like. It has a point at the origin, and it's a v shape. Square root of x is the parent function on this one. We know that that starts at the origin and kind of hooks off to the right. And this parent function is y equals x squared, and we know that's going to do the u shape. So be very careful. Make the u's look like u's, and for absolute values, make them look like v's. And then I'm going to use, here, let's use this purplish color. So let's see what happens when we put negatives in front of our functions. So y equals negative x to the third. Oh, look at that. It looks like it just snakes the other way. So the graph still has this same origin point, but it's going to snake the other way. Okay, so that's going to be the actual function. Y equals negative absolute value of x. Let's see what happens here. Oh, look, it just goes down instead of up. So the graph will look just like the parent, but it'll just go the other way, like that. And then negative square root of x, let's see what happens. It just goes down instead of going up. So it kind of looks like this. So what do you think is going to happen with the negative x squared? All these others, it looks like whatever went down went up, and whatever was going up went down. So here they're both going up, so now they go both down. So I'll bet this one will just do that. Okay, so what's going to happen? So negative f of x flips, I'm going to use that in quotes, graph the opposite way. But the technical definition, so that's kind of the way to think about it, but what you really want to say is that it is a reflection over the x-axis. So whenever you have a negative in the front of your function, you know that eventually you're going to have a graph that flips to the other side of the x-axis. So it's a reflection. Okay? All right, so let's summarize here. So to summarize, when we have a plus k at the end, remember that means we shift up k units. This is terrible looking, sorry. So shift up k units from y-intercept. So just be careful with that. Most of the time, that plus k tells you what value to go up to. But remember that exponential function or any other function that has a y-intercept that is not the origin, it may not exactly tell you the number, but it tells you how much to shift up. If we have minus k here, it means you shift down k units from y-intercept. Okay. If we have f of x plus k, so I'm going to put stars next to these two because these are the ones that I call the weird ones. So this says plus k, but we actually shift left k units. When we have the minus k, another weird one, that minus k being inside the function, that shifts right k units. And then remember, a negative in the front tells us that we're going to reflect or flip over the x-axis. Now, I will tell you that when you're looking at that flipping one, if you have other transformations occurring first, you always do those other transformations before you do the flip. So if you have to shift left and up or right and down or whatever it may be, you have to make those shifts before you do the reflection because it's not really always going to be just it goes down. It's going to be, it goes down. It's a reflection from wherever its starting point is over the x-axis. Okay, so what we're going to do is we're going to practice doing some transformations. I am not going to focus on domain and range right now. Right now our focus is on being able to do these actual functions, okay? So for this one, I see two transformations. This one is inside, so it's a weird one. We're going to say it goes right 2. And this part tells us we go up 4. The parent function is y equals x squared, so normally we'd start at the origin. We're going to shift it right 2 and up 4. And then we're going to graph it like a parabola. Okay, let me make that look a little better. Trying to make sure it looks like a U. This next one, I see 3 transformations. So first, we have a -3 inside the function. So remember, that's the weird one. So we're going to write 3. The -1 at the end is going to tell us to go down 1. And the negative in the front tells us we have a flip or a reflection. So remember, we have to go right 3 and down 1 first. Now the parent function for this is y equals x cubed, so it's going to look like that snake. Normally it has a point on the origin, so we're going to send it right 3 and down 1. Now normally, don't draw what I'm about to do, but normally you would have a graph like this, but the graph isn't going to look like that because we have a flip. So what's going to happen instead is that we're going to graph like this. Okay. And then we'll look at this one right here. This one, I see we have a +1 in the function, so that's a weird one. So we go left 1, and this tells me I go up 4. Now it's a square root function to start with, so we're going to start at the origin. We're going to send it left 1, up 4, and then the square root function looks like that. Okay? I'm not going to do this one right here, but I do want to talk about these last two. This one is absolute value function, so we got inside the function here, it's a weird one, so we go right 3, and this tells me I go down 2. Absolute value functions normally start at the origin. We're going to send it right 3, down 2. There was no flipping, so we just draw our V. This one here, remember the y-intercept is at 0, 1. So when we're thinking of our shifting, we have to be shifting from that point. All right, so let's see. We got a +1 here that's with the function. That's a weird one, so we go left 1. And the -3 tells us we go down 3. Now remember, we're doing these from the point 0, 1. So start here. We're going to go left 1 and down 3. And then the graph just kind of looks like this. Okay. All right, I think that's enough to get us through this video. We'll talk more about these shifts in class and hopefully make more sense of it then. But for now, you should at least have enough info to try out the questions that are on Delta Math.